Alright, we're taking a look at simplifying radicals and all the rules that go along with them. Please remember that what we've been doing all along, I know I would have x to the 11th there because I added 7 and 4. That's the same thing as when I add 2/3 and 1/5. We just have to remember how to get a common denominator 15 to get 13/15ths. We're just adding when we have the same base. When we have a problem like this, we know we would get x squared. We subtracted 5 minus 3, or there are 2 more x's on the top than the bottom. So in a problem like this, even though they're fractions, we're doing the same process. We're just subtracting. We make that 2/4, so altogether we have x to the 1/4. We subtracted. When we raise a power to a power, we know we multiply. That's x to the 8th. So even when we have fractions, if I have 3/4 times 8/7, the 8 and the 4 cancel, and that would be x to the 6/7. So multiplying when you raise a power to a power. Don't let the fractions change what you've been doing for years. But the new thing with all the rational exponents are the 3 rules. So let's tackle a group of problems at a time. Let's start off with no negative exponents. If I see a negative exponent, I have to write it as 1 over x to that number. If I have x to the negative 5th, that's 1 over x to the 5th. A negative exponent on the bottom would have to come up. That would be 4 times 3 squared, or 4 times 9, or 36. So all of a sudden something really ugly can get pretty. And again, a negative exponent on the bottom comes up and it's positive. So if you have variables in both areas, if you have a negative on the bottom, it comes up. A cubed times a to the 4th is a to the 7th. If it's a negative 2 on the top, you would bring that down. If you bring down everything, there's a 1 up there. That would leave you with 6 b's on the bottom. A negative on the top and bottom, you might want to take a step there where you look at it normal, and you can see that that's c to the 4th, or you could have just subtracted negative 5 minus negative 9 and gotten c to the 4th that way. So if you have one outside of a fraction, the cool thing is that the fraction itself flips, and then the exponent becomes positive. So that would be 16 over 49. So that's taking care of negative exponents. The next section is this idea that you can't have fraction exponents in the denominator, which really means since fraction exponents are another way to write radicals, it's the reminder to rationalize your denominator. If you have a square root and you have to get rid of it, you would leave that as 3 root x over x. If you had a cubed root, you would have to get enough a's underneath to make it go away. In this case, a squared. That would leave you with 7a cubed root of a squared, ugly on the top, over, well, look at that at the bottom, just an a. And that's a cool problem. You have to keep going. So sometimes it seems like the problems keep going. It's just because you have something canceled. In this problem, I have a 4th root, so I would have to have enough x's underneath that I make 4 of them. That would require an x cubed. So a negative 5's on the top, a 4th root of x cubed, and then on this bottom, this gives me just the plain x that I'm looking for. And sometimes if it's a number, this is uncomfortable to look at, so you can keep it with a fraction, or I see many of you like to rewrite it as a radical, and that helps you just to remember that that is a 4th root of 3 cubed that you're trying to multiply both sides by. On the top, you have a 4th root of 3 cubed, 3, 9, 27, and on the bottom, just the plain 3, and you'd stop there. So that's that funny rule. No fractional exponents in the denominator just means no radicals. And the last one that we have is talking about no improper fraction. Improper fraction, bigger number on top than bottom. So a couple things to remember. If we had to rewrite this, bottom number goes in the hook, so it's the cubed root of y to the 15th. This is the cubed root of x to the 9th. This is the cubed root of x to the 11th. These are all what improper fractions look like in a radical. So no improper fractions in the exponent says if you have a problem like a number, go ahead and remember your special facts. Why does that work? Because 4 cubed is 64. If you divide 15 divided by 3, you have 5 y's that come out. If you divide 9 by 3, these are all pretty. So what do you do when you have leftovers? You can look at it in a couple different ways. Think of that as x to the 9th times x squared. So 3 of them are going to come out, just like they did here, but then you have 2 left over. So if you put all those ideas together, we know the cubed root of 64 is 4. The cubed root of x to the 11th, well, part of it's nice, part of it is not. The cubed root of y to the 15th is y to the 5th. So that's why our answers look so funny. It's just multiple parts done in the same problem. And finally, another way to look at this. With this last rule, that's sometimes awkward. Another way to look at it is if the exponent underneath the radical is bigger than the index, you have a problem. That's just another way to look at improper fractions. Good luck.